Hello again. Let's talk about function notation and working with function notation as you'll be doing in section 2.1. As I mentioned in the previous video, y equals x squared is an equation that defines a function because every input x will lead to one and only one specific output y. Typically in that situation, we will prefer describing the function with function notation rather than using y. We'll substitute f of x. And this notation has a number of advantages in over just using the output variable y. And in section 2.1 you do a lot of homework where you have to simplify or evaluate various expressions using function notation. You kind of see some of the power of this. I have a couple of other equations here that also define functions. If I input an x, I take x and divide by the quantity, the square of x minus 1, I get a unique real number output. That could be described as g of x equals this formula. Typically, function notation uses f or g or h or I or small letters near the middle of the alphabet. It can use other letters or symbols as well. And let's call this third function h of x. Just using this notation rather than the equation notation. And then let's do some simplification over here with some expressions that use function notation. So f of negative 3, it's like you look at this guy for the definition of what function f is. And f is the function that takes any input, x, and outputs the square of x. So f of negative 3 is the square of negative 3. And of course, I'm just substituting negative 3 into this formula. F of negative 3 is 9. I'm sure that's familiar to you. But this is where it starts to get a little bit murky sometimes if students are rusty with function notation. Here is f of the opposite of x. It's a very compact way of saying what is the output from this function f, defined by that formula. What is the output when the input is the opposite of x? Basically, anything that's in the parentheses here gets dropped into the formula right where the input variable is, every place the input variable is in this formula. And then I'll square the opposite of x. I actually just get x squared. Later we'll observe that this is an indication that this is an even function, because if the output for the opposite of x turns out to be the same output, equivalent to the output for the original function, we're looking at an even function that will have a certain symmetry properties with its graph and its algebra. How about, on the other hand, here's f of opposite of x. What about the opposite of f of x? This is just saying with the notation, what's the opposite of this formula? Here, it's an order of operations thing, right? The squaring is occurring before the opposite sign is being applied. So I would get the opposite of x squared from my output there. How about f of an expression? So this is saying, what do you get when you input a number plus 1, input plus 1, or this formula into this function? Well, whatever appears in the parentheses here is dropped in to this formula in the place of x. So this is the squaring function. Every input outputs the square of x. So when I input x plus 1, I output the square of x plus 1. Be careful here. I hope I don't have to put the intermediate step in there, but Sometimes at the beginning of the course I'll get x squared plus 1 when people square this binomial. Of course, what's going on here is the square of x plus 1 is x plus 1 times x plus 1, and in slow motion we would have to attend to the first product of terms in the binomial, the outside product 1 times x, the inside product 1 times x, and the last products of the last two terms, and of course that combine the middle terms that you have x squared plus 2x plus 1. I know that's familiar algebra for all of you, but it's easy to forget. How about g of x plus 1? Here g is this somewhat more complex rational function. I'm calling it rational because it's a fraction. If I drop, I have to look at the input here, x plus 1, and substitute that for every instance of x that I see in the formula. It can be confusing, frankly, because x is being used more than one way here. I've got x in the formula that I'm dropping in here for the input, and I also have x used to describe how the function behaves. What this function does is it takes any number you give it that's in its domain and takes that number divided by a quantity that's the square of that number minus 1. So here I just need to copy that formula down, but substitute x plus 1 every place I see an x in the original formula. Sorry, I'm having trouble not standing in front of my work here. And then of course I've got some simplification here in many cases. So down here I'll square this out. Then subtract 1. And I can get to here. Is there further simplification? I could factor an x out of the denominator, but there's no factor of x in the numerator, so I won't be able to cancel factors. And I certainly couldn't cancel rather an x here and here, or here and here, because these are terms, things that are being added in these expressions, not factors, not things that are being multiplied. So unless the numerator and denominator factor, there's not going to be any canceling here. Let's look at a couple more examples. Maybe I can ask you to try. Am I up to A, B, C, D, E, F, G or so? I don't know. Maybe you want to pause the video for just a second and see if you could come up with a simplified version for g of 3x. Here's g. What would g of 3x be? You're pausing this, aren't you?